You know that moment you open a cupboard and you're hit by that weird, funky, stale smell? We've all been there. It's a pretty common kitchen annoyance, right? But what if I told you that simple off smell is actually the tiny local signature of a massive global chemical process? So what is really going on inside that stale bag of chips? Let's dive in. I mean, it's that exact feeling when you take a bite of a chip that should be crispy and it just tastes, well, wrong. Or maybe you've noticed your cooking oil has a strange, almost paint-like odor to it. That's not just in your head. It's a very specific chemical breakdown happening right there in your pantry. And there's an official name for this: rancidity. It's just a scientific way of saying that the fats and oils in your food are going through chemical changes that create those nasty tastes and smells. But what's actually happening on a microscopic level? Well, let's meet the villain of our story. It's a process called lipid oxidation. This is the core chemical reaction that's responsible for turning your favorite fatty foods from absolutely delicious to, well, pretty disgusting. So, to put it simply, lipid oxidation is what happens when fats basically go to war with oxygen. And this reaction is seriously bad news for our food. It doesn't just make things taste bad, it drastically shortens shelf life, it destroys essential nutrients like fatty acids and vitamins, and it can even create compounds that are toxic to our cells or, in some cases, even carcinogenic. And here's where it gets really interesting. You know all those good fats we're constantly told to eat? The unsaturated ones you find in olive oil, avocados, and nuts? Well, the very chemical structure that makes them so healthy, all those double bonds, also makes them way more vulnerable to oxidation. It's a total paradox. The thing that makes them good for you also makes them spoil fast. So, how exactly does this attack happen? Well, lipid oxidation isn't just one single thing. It actually follows three main pathways. Let's break them down one by one. First up, we've got auto-oxidation. You can think of this one as the slow, relentless march of spoilage. It happens all on its own, just at room temperature. Scientists call it a free radical chain reaction, which is basically a microscopic domino effect, where one unstable molecule kicks off a whole cascade of damage. It all kicks off in the initiation phase when one unstable molecule, that's our free radical, gets formed. That's the first domino falling. Then comes propagation, where this radical creates another, which then creates another and another, in a self-sustaining cycle of destruction. This chain reaction only stops when two of these radicals finally bump into each other and cancel each other out. That's called termination. And what's really key to understand is this vicious cycle you see right in the middle here. A damaged fat molecule reacts with oxygen. This new nasty combination then goes and attacks a perfectly healthy fat molecule, damaging it and creating a brand new attacker. You can see how the reaction just keeps fueling itself, going on and on and on. Now, if auto-oxidation is a slow march, our second pathway, photooxidation, is a full-on lightning-fast sprint. It's triggered by light, and get this, it can be up to 1,500 times faster. This is exactly why your fancy olive oil often comes in those dark green bottles. It's to protect it from light and this incredibly rapid form of decay. So here's how this one works. Something in the food, like chlorophyll in olive oil, absorbs energy from light. It then passes that energy over to an oxygen molecule, turning it into a supercharged version called singlet oxygen. This stuff is so reactive, it doesn't even need a chain reaction. It can just directly attack the fats, causing spoilage almost instantly. Okay, our third pathway is a whole different ballgame. This one isn't random. It's a targeted biological attack. It's called enzymatic oxidation, and it's driven by enzymes, like one called lipoxygenase, or LOX for short, which are naturally hanging out in a lot of raw foods like plants, fish, and meat. So what's the big difference here? Well, this table lays it out pretty clearly. Auto-oxidation is that random, free radical chain reaction that happens while food is just sitting in storage. But enzymatic oxidation is a highly specific, enzyme-driven process that happens in raw tissues. It's really the difference between a random mob causing chaos and a skilled assassin with a specific target. Okay, so we've just gone through the nitty-gritty chemistry that makes your food go stale. But now we're going to zoom way, way out, because this tiny microscopic reaction has massive consequences for every single one of us.
See, this process of lipid oxidation, it's not just happening in your pantry. It's happening in every grain silo, every shipping container, and every farmer's field all around the world. And when you multiply it by billions, it becomes a major driver of a true global crisis.
Just look at this number for a second, 20 to 30%. In a country like Nepal, That's the percentage of all fruits and vegetables that are lost after they're harvested, before they ever even have a chance to reach someone's plate.
This is what's known as post-harvest food loss. And the very same chemical processes we just talked about, autooxidation, photooxidation, and that enzymatic one, they are the main culprits behind so much of this waste on that long journey from the farm to your fork. Let's just use Nepal as a quick case study. You've got tons of small farms that don't have access to modern equipment. There's a serious lack of cold storage, which you need to slow down these chemical reactions. Then you add in rough transportation over difficult terrain and high temperatures, and you have created the perfect storm, an absolute breeding ground for lipid oxidation to just run wild and spoil food.
And this all brings us to the real takeaway here. Understanding this chemistry isn't just some abstract science lesson. It is fundamental to tackling one of the biggest challenges we face as a planet: food security. The impact is just devastating. I mean, this quote really says it all. When food spoils, farmers lose their income, the amount of food available for everyone shrinks, and ultimately a whole nation's ability to feed its people is put at risk. And all of this can be traced back to those tiny invisible reactions between fats and oxygen. So we have to end with this thought. We've managed to decode the science of spoilage. We know the enemy. It's oxygen, light, heat, and time. The real question now is, how can we apply this microscopic knowledge on a macroscopic global scale? How can we use it to protect our food, support our farmers, and finally start to build a world with far less waste?